More than 50 years ago, humanity first set foot on the moon. Back then, no one could have imagined that one of the greatest treasures in history was buried beneath their feet, covered by a thin layer of gray dust. Forget everything you've ever heard about gold, oil, or diamonds. The race for wealth has a new stage, and it's happening silently, far from Earth, on a cold, hostile, and seemingly lifeless world. The moon. The reason? A rare and invisible gas, virtually non-existent on our planet, but with the power to revolutionize how we produce energy, forever. Its name is Helium-3. With it, we could eliminate global dependence on oil, stabilize nuclear fusion, and for the first time in history, generate clean, sustainable energy. On a massive scale, entire cities could be powered by an almost unlimited source of fuel. And more than that, it could make space colonization possible, with permanent lunar bases and far more efficient rockets. All of this, thanks to an element that has been silently accumulating for billions of years on the moon's surface. The new space race is already underway, but this time, it's not about who plants a flag. It's about who seizes the most valuable fuel in the history of humankind. The first nation that manages to master and extract this element will secure much more than just its own energy independence. It will have the power to reshape the global balance. China has already mapped the moon's richest deposits of helium-3. The United States plans to send astronauts back by 2027. Meanwhile, Russia, India, and Europe are forming their own strategies. Which raises an inevitable question. Are we on the verge of one of the greatest revolutions of the modern era, or about to enter the first space war in history? Prepare to dive into one of the most intense and quiet races of all time, and everything that's about to unfold on lunar soil in the coming years. My name is Lucas, and you're watching Deciphering. When Neil Armstrong took his first step on the moon in 1969, he wasn't just making history, he was carrying what would become one of the most valuable discoveries of the century. The lunar soil samples, collected by the Apollo missions, were brought back to Earth and studied for decades. At first, they were just dust and rocks, but over time, something unusual began to catch scientists' attention. Trapped within the particles of lunar regolith was a gas, extremely rare on Earth, but present there in surprising quantities. That gas is helium-3, and its energy potential could forever change the future of humanity. To understand its true importance and why it's so highly sought after, we first need a quick look at how we produce energy today. The world still relies heavily on fossil fuels like coal, oil, and natural gas. These resources generate energy by burning, but also release harmful pollutants, making them one of the main drivers of global warming. In other words, they're not a sustainable energy solution in the long run. Cleaner alternatives, like solar and wind energy, do exist, but they also come with limitations in generation capacity and storage. And that's exactly where helium-3 stands out, not just as an alternative, but as a truly revolutionary energy source. It's considered the ideal fuel for a process called nuclear fusion, the same process that has kept our sun burning for billions of years. In fusion, light atoms merge into heavier ones, releasing an enormous amount of energy, a clean, abundant, and virtually limitless energy. The problem is, to this day, no lab on Earth has been able to fully stabilize nuclear fusion. That's because the fuels currently used, like hydrogen and tritium, are extremely unstable, dangerous, and still produce radioactive waste. Controlling them demands an enormous amount of energy, So much that the math simply doesn't work. But with helium-3, everything changes. Because it's a more stable element, it allows for cleaner and safer nuclear fusion, with zero radioactive waste. And with just a few kilograms of helium-3, entire cities could be powered for months, or even years. To get an idea of its potential, it's estimated that just 40 tons of helium-3 could provide enough energy to power the United States for an entire year. That's an absurdly smaller amount of fuel compared to the millions of tons of coal or oil used today to achieve the same result. On top of that, helium-3 would be virtually inexhaustible, considering the massive reserves that have been building up on the moon's surface for billions of years. That's why the world is once again turning its eyes to the moon. This time, not as a symbol of conquest, but as a new El Dorado. Countries like China and the United States have already begun a new space race, and the destination is clear: lunar mining. Whoever gets there first, builds the first base, and manages to extract this precious gas, won't just be securing its own energy independence. They'll be shaping the future of humanity with unimaginable power in their hands. But how did this rare gas end up on the moon in the first place? And what exactly are humanity's plans to go after it? Unlike Earth, the moon has no atmosphere and no magnetic field. That means that for billions of years, it's been fully exposed to a constant bombardment of charged particles from the sun, the so-called solar wind. And it was through this silent, relentless process that one of the most valuable elements in the universe began to accumulate: helium-3. Locked in tiny amounts within lunar rocks and regolith, it spread across virtually the entire surface of our satellite. Here on Earth, this gas is almost non-existent. That's because our magnetic field acts as a natural shield, preventing solar particles from ever reaching the ground. The moon, however, with no such protection, has become the largest known reservoir of helium-3 in the entire solar system. And the plans to extract this priceless resource are becoming more advanced with each passing year. The most viable proposal so far is to use autonomous, tractor-sized robots to dig up and collect tons of lunar dust and rock, acting almost like giant vacuum cleaners. Then, the material would be heated to over 1.12 degrees Fahrenheit in a controlled sublimation process, releasing the helium-3 trapped within the grains. Is it possible? In theory, yes. But in reality, it's a far greater challenge. For every ton of regolith processed, scientists estimate that only 20 to 30 milligrams of helium-3 could be extracted, which means that to obtain a single kilogram, you'd need to mine between 30 and 40 million tons of lunar soil. And that brings us to another question. How can we ensure these robots operate 24 hours a day in such an extreme and unforgiving environment? How do we store, process, and transport this material on a large scale? And perhaps the most critical question, how do we bring this treasure back to Earth, safely and economically? Despite the complexity, we're moving quickly towards solutions. NASA's Artemis program aims to establish a sustainable human presence on the moon by the late 2030s. There, they plan to test autonomous mining systems, solar power generation, air purification, and pressurized habitats, all designed to make long-term surface missions possible. Meanwhile, SpaceX is working to make transportation between Earth and the Moon increasingly accessible with its fleet of reusable rockets. The Falcon Heavy, for example, is already capable of transporting 16.8 tons to the Moon, or 63.8 tons to low Earth orbit, a capacity comparable to the legendary Saturn V used during the Apollo missions. But here's the big difference. It can do it at over 10 times less the cost per ton sent to space. Meanwhile, China is advancing rapidly and quietly. Its Chang'e 4 and Chang'e 5 missions not only brought back fresh lunar samples, but also conducted the first ever detailed mapping of the Moon's richest helium-3 deposits. A piece of information so valuable that no other nation possesses it. In partnership with Russia, China has bold plans underway and intends to establish its own lunar base by 2030. India, Russia, and Europe are also in the race, each with its own exploration programs and international partnerships. The problem: there are still no clear laws on how this resource can be exploited. Who will be allowed to mine helium-3? How will lunar territory be divided? Or even more troubling, what happens if two nations claim the same prime mining sites? These are just a few of the many questions still unanswered. And when a resource this rare, powerful, and virtually inexhaustible is at stake, the risk of conflict becomes only a matter of time. The Moon is more than 238,000 miles from Earth, but the conflict brewing there is much closer than it seems. For decades, space was seen as neutral ground, a stage for science, curiosity, and the progress of humankind. But now, it has become a silent battlefield, where global powers compete, each in their own way, for the new ambition of the century: space mining. And the problem is, in this game, there are no clear rules. Contrary to what many think, the Moon doesn't belong to anyone. Not to NASA, not to China, not to any country on Earth. In 1967, more than 100 nations signed the Outer Space Treaty, which stated, "No celestial body, including the Moon, may be claimed by any nation." The idea was noble: to ensure space would be used only for peaceful purposes, for the benefit of all humankind. But time passed, technology advanced, and the treaty was left behind. It bans territorial claims, but it doesn't forbid commercial exploitation, doesn't define who can extract resources, or how they should be shared. It doesn't even establish oversight or penalties if a nation decides to act solely in its own interest. Which leads us to an inevitable question. If no one can own the Moon, then who will have the right to exploit it? Years later, an attempt was made to fill those gaps. The so-called Moon Agreement. This time, it included more specific clauses, clearly banning commercial exploitation without a collective agreement. But what seemed like a solution was ignored entirely. The world's main space powers, the United States, China, and Russia, refused to sign it. And so, the Moon remains a land without laws, no territorial division, no mining regulations, no guarantees that this race will end peacefully. Today, the world's attention is focused on one specific area of the Moon, the lunar South Pole, a strategic region that offers everything a future settlement could need: nearly constant sunlight, hidden water ice beneath the surface, and, of course, high concentrations of helium-3. It's precisely there that both the United States and China plan to establish their first permanent bases. Both know that whoever gets there first will hold a unique and possibly decisive strategic advantage. But what will happen when mining bases are built over helium-3-rich ground? Will that nation have the right to exploit it freely, selling it to whoever they want, at whatever price they choose? Or will they be pressured to share it with the rest of the world? Officially, the lunar race is still peaceful, but behind the scenes, the story is very different. The United States has already declared space a strategic domain of national security, and China rejects NASA-led agreements, preferring to create its own protocols and alliances. Both sides have made it clear: if they must protect their interests, they will. A new Cold War is taking shape, and whoever wins it won't just secure a piece of the Moon, they'll hold the power to fuel the entire planet for generations. And perhaps, to redraw Earth's geopolitical balance. But is this truly the path we're going to take? A race driven by self-interest, when we could be joining forces? After all, this isn't just a dispute over borders. It's a unique chance to rethink humanity's future. Because the moon could be far more than a territory to be conquered. It could be the bridge to our future. And everything depends on the decisions being made right now. The moon, our natural satellite that has shielded us for billions of years, is often treated as a trophy to be claimed, but it can be far more than that. Because Helium-3, as valuable as it is, isn't the only treasure hidden there. Lunar soil also contains rare elements such as platinum, titanium, and rare earth metals, essential for advanced technologies like satellites, batteries, and electric vehicles. And beyond its resources, the moon's unique position in space makes it the perfect launch pad for the next great steps in space exploration. A kind of cosmic pit stop where we could refuel, conduct research, and prepare to go further. With regions of near constant sunlight, deposits of water ice beneath the surface, and lower gravity than Earth, the moon offers exactly what we need to turn interplanetary journeys from science fiction into reality. It could become a bridge between Earth and Mars, and even serve as a base for mining asteroids and comets that drift through our solar system. In the end, it's not about who gets there first, or who plants the most flags. It's about what we choose to build once we arrive. If you enjoyed this video, subscribe to our channel for more high-quality content about space. My name is Lucas, and I'll see you on the next mission.